oxygen level, Celis? What's going on? I heard the alarm, I heard screaming. Tell me, a bomb? Several bombs are going to go off in major cities? And the terrorist left a message for me. What does he want me to do? Oh, the key to stopping the bombs is solving a related rates problem. Ah, he definitely has gotten funny over the years, or so he thinks. He's my arch nemesis. I hate him. Sorry, yeah, the bomb. Please assemble a team of great agents and good at calculus as well. We're going to save the world, don't worry. Yes, we'll save the world. I always save the world. Trust me. Hello. You must be the group of agents assembled for me. Are you ready? You have to be ready anyways. That's just a courtesy question. Get started with our problem. First, we're going to read it. The abdiatic law, no gain or loss of heat for the expansion of air is pressure times volume to the 1.4 equals C, where P is the number of pounds per square units of pressure, V is the number of cubic units of volume, and C is a constant. At a specific instant, the pressure is 60 pounds per unit squared and is increasing at a rate of 10 pounds per inch squared. Each second, if C equals 5/16, what is the rate of change of the volume at this instant? Let's picture our problem in order to get our imaginations going on. We know the pressure we have is 60 pounds per inch squared. We know that our constant is 5/16. We know that our pressure, the rate of change of our pressure is 10 pounds per inch squared, and it is increasing every second. What we don't know is our initial volume or the volume we have, neither do we know at what rate is this volume changing, which is what our problem is asking of us. As I said, the givens are the pressure, the rate of change of the pressure are constant, and the unknowns are the volume and the rate of change of this volume. In order to solve any related rates problem, you need to associate an equation that has all of the variables in question. The problem gives us that equation, which is pressure times volume to the 1.4 equals C. The first step would be solving for volume. In order to solve for volume, we grab the previous equation, and that will give us C divided by pressure to the root of 1.4 equals volume. We replace the variables with C being 5/16 and pressure being 60. And when we solve it, it gives us that volume is 0.2339 inches cubed. After doing so, we start with a little bit more difficult parts of the problem. We derive individually in the equation that was given for us. We know that P, the derivation of P equals its rate of change, which is dP/dt, also times 1, but technically we all know that it's multiplying times 1. Also, the derivation of P to the 1.4, we are going to use the power rule. We move the 1.4 multiplying V, and 1.4, the exponent, we subtracted by 1, times dV/dt because we are using implicit differentiation. This would equal 1.4 times volume to the 0.4 times dV/dt. And now we're going to derive C using the constant rule. We know that every constant, when derived, equals 0. And then we apply this into our equation. The first rule we're going to use when deriving the equation as a whole is product rule. We know that P times the derivation of P to the 1.4, which is 1.4 times P to the 0.4 times dV/dt, plus P to the 1.4 times the derivation of P, which is dP/dt, as I said before, equals the derivation of C, which is 0, because again, it is a constant. When we apply our product rule, this is what it gives us. The third step is to replace our variables. As we know pressure, we know volume, and we know the rate of change of our pressure. So that will give us 60 times 1.4 times 0.02339 to the 0.4 times dV/dt plus 0.02339 to the 1.4 times 10 equals 0. And then we're going to solve for what we're looking for. As you see, the only variable we don't have is the rate of change of volume, which is what we need. So we're going to move the 0.02339 to the 1.4 times 10 to the other side, and that will give us negative 10 times 0.02339 to the 1.4. And then we know that 60 times 1.4 times 0.02339 to the 0.4 is multiplying the variable that we need, which is the rate of change of volume. So we pass it to the other side, dividing, and that would equal negative 10 times 0.02339 to the 1.4 divided by 60 times 1.4 times 0.02339 to the 0.4. Once we solve the equations, we multiply the top and the bottom and divide top with bottom. It will give us that the rate of change of volume equals negative 0.0028 inches cubed per second. Congratulations, agent. You just saved the world. I know, I always save the world. We had nothing to worry about. It was a pleasure working with you.